Thank you all for having me. I drove here tonight with my bodyguard, my good friend Lawrence. Lawrence, raise your hand. I like to embarrass Lawrence. I was telling Lawrence on the way up here, I haven't been here to Charleston since I was about 6 years old. But it's a lovely city from what I've seen so far. We just had some excellent Jim and Nick's barbecue, so go Jim and Nick's. There's some Jim and Nick's fans in the audience. Woo! Yeah, make some noise, that's right. So definitely, I want you guys to make some noise and be interactive. I don't like boring presentations, and I'm sure you don't either. So I'm going to be asking questions, and I expect some answers. If you don't answer my questions, then it'll be like Chris saying disgusta. You might have to have some words. You're not going to live that down.
I'm counting on it.
I'm going to remind you of that for a long time. So as Chris said, I am Doug Burks, and the obligatory who am I slide. First and foremost, I'm a Christian husband and a father, and in my spare time, I'm a security guy. So I'm the Deputy Chief Security Officer for Mandiant, so it looks like we have 3 Mandiant folks in the house tonight, so that's pretty awesome. For those who aren't familiar with Mandiant, we are the premier company in the world when it comes to dealing with Chinese and Russian hackers, so nation-state sponsored adversaries. We have the world's greatest intelligence library built up about what these attackers are doing and how they will stop at nothing to get into your networks and get your intellectual property. For those of you who may be looking for work, we are always hiring. It's an awesome company to work for. Can I get some amens?
Amen.
Yes, it's a great company to work for. We're always hiring for sharp security folks like yourselves. So if you're interested, go to mandiant.com. We have a jobs page. Lots of very cool jobs, from incident handling, incident response, to pen testing, to forensics, to rootkit development, to just about anything you want to do in the security realm. So that's Mandiant. I also, as Chris mentioned, I'm a SANS GSE, and I'm a community instructor. So I teach intrusion detection for SANS. I'll be teaching a class on log management in Memphis in just a few weeks. So if you're interested, you can go check out my Twitter or my Security Onion page for more details. I am the president of the Greater Augusta-ISSA. So we actually started probably about 6 or 7 years ago now. Our chapter is probably roughly the same size as the group that you have here tonight. We average about 40 folks per meeting. And one of the things that we did for the first time this year, myself and Mark Baggett, we've been threatening to do a security conference for many years now. So this year, back in March or so, we were sitting around at a barbecue restaurant where all the best stuff happened, right? And we said, okay, this is the year. And Lawrence said, okay, what do we got to do to get B-Sides Augusta done? And I said, Lawrence, initiative is not granted, it is taken. And so Lawrence has taken the ball, and he has run with our B-Sides Augusta, which we just had this past Saturday, and it was a tremendous success. So how many folks happened to make it out to B-Sides? I know Mark was there, and David was there. David was a great presenter, Jackie was there. So you guys who missed it, David did a great job presenting. He gave a great talk on Emmett, and I was very impressed. So we do plan on making B-Sides Augusta an annual event, so make sure if you didn't make it this year that you make plans to attend next year. And the reason I'm here tonight, I am the founder and lead developer of Security Onion. So let's talk about that. Our story begins in 2008. So I was a defender tasked with defending my network, and I said, you know what, I need an intrusion detection system. But you know, more than that, more than just an IDS, I can't just rely on IDS alerts alone. I really need network security monitoring. So who is familiar with the concept of NSM? I know Chris is. Chris happens to be writing a book on the subject. So NSM, so somebody tell me something about NSM. Let's be interactive.
Packet analysis.
Packet analysis, okay. That's one aspect of NSM. What's another aspect of NSM?
Prevention eventually fails.
Prevention eventually fails. Very good. Anything else? Yes, sir.
Tracking how they got in and how they got out.
So intrusion detection and extrusion detection as well. Very good. So one of the things that is kind of one of the core tenets of network security monitoring as a methodology is that IDS alerts alone are not enough, right? So many organizations, they purchased a commercial IDS appliance. It's generating these IDS alerts, but that's really not enough data, right? So let me give you an analogy. So you've got a house, right? You want physical security for your house. So you go buy a security system, right? They come and install it, you find out that it's really a motion-activated camera. So if somebody approaches the door, it takes a snapshot. So you don't know if the guy knocked on the door and ran away, or if he broke down the door and stole your 3D TV, right? But if you have videotape, then you can rewind the videotape and you can see exactly what happened before the snapshot in time and after the snapshot in time. Network security monitoring says we need full packet capture. We need that videotape to be able to rewind. So we have this idea of NSM. Let's talk about an implementation. So 10 years ago, this great guy named Bam Fisher, he wrote this tool called Squeal, which is the open source de facto reference implementation of network security monitoring. As I said, it's 10 years old. It's not the most beautiful program in the world. It's written in TickleTK, but it's highly functional, very powerful. So let's talk about what Squeal looks like from an architectural standpoint. So if you start off with your Snort IDS alerts, right, this is what everybody in the world has. Everybody has IDS, but what we're talking about with NSM is surrounding those IDS alerts with context, right? So let's include PADS data, so Passive Asset Detection System. So this is things like passively identifying that this IP address on my network is running Windows XP. Then we also have session data. So if you're familiar with Cisco switches and Cisco NetFlow, that's a form of session data. This IP address talked to this IP address, this many bytes, this many packets. And then we have full packet capture. So we take all of these data types, and then we have agents which collect the data, and they send it into SquealD, which is the central collection service, which then stores it in a MySQL database. And then you as the analyst, you can then make requests, and you can say, hey, show me everything you know about this IP address. You can pivot between data types, and you can solve the investigation because you're not just relying on IDS alerts. You have all of this data at your disposal. So that's a lot of data, and that's a lot of pieces in the jigsaw puzzle, right? So has anybody ever tried to compile and configure Squeal by hand? Yeah, I see a couple of people nodding. How successful were you? Not so much, not so much. So I hear that all the time, because every time I do this presentation, I ask that question. And truthfully, the number of people who responded that they successfully compiled and configured Squeal by hand in a reasonable amount of time is something like 1%, right? Most people, if they didn't just give up, it took them days or weeks or months to get all this stuff going, all of it configured together. So I said, you know, there really ought to be a contract for blue teams. You know, I'm looking for this ISO image that I can just download and I can boot it and install it and click next, next, finish, and just be up and running with all this magical software that's going to help me. But it wasn't there. So I cried. And then I came to the realization that if it's not out there, if nobody's built it yet, I guess I have to build it. So in 2008, I started working on it. In 2009, I released the first version. It's based on Ubuntu. It included Snort and the lovely Squeal client, as you see here. So you can see your events up top, and you can see your IDS rules and your IDS payload, and you can see all your lovely agents running down there. And so I released it on SourceForge, and nobody downloaded it. And so I cried again. But hey, I had next finish for NSM. Nobody really cared, but I achieved that goal. That was my goal, and I achieved it. So the next year, 2010, Ubuntu released their next version, Ubuntu 10.04. So I said, okay, it's time for a new version. So I added Suricata. Suricata is an open source competitor to Snort, free open source intrusion detection engine. I added OSSEC for host-based IDS. So somebody tell me why I might want host-based IDS in addition to network-based IDS. Yes, sir?
You got to figure out what's going on around your host as well as outside.
True, so in addition to monitoring maybe just my perimeter, maybe I want to see the hosts themselves, watch for activity directly on the host. Let me give you a good example of why I really love using OSSEC as a host-based intrusion detection system. So let's imagine you've got a web server sitting in your DMZ. Right? Chances are that web server is running SSL, right? You're not doing clear text HTTP, you're doing HTTPS. If I've got Snort or Suricata monitoring that traffic, am I seeing anything? No, the traffic is encrypted. So an attacker does a SQL injection attack against my Apache web server doing HTTPS, I'm blind. But if I have OSSEC installed on that web server, it's monitoring my Apache log files, attacker does a SQL injection attack, OSSEC sees that in the log files and says, hey, just detected a SQL injection attack. Whereas once I was blind, now I can see. So it's all about increasing visibility. So then I also added Squirt, which is a web-based interface to the Squeal database. So as you saw in the previous slide, the Squeal client is written in TickleTK. It's not pretty, it's not browser-based. So folks wanted a browser interface, so I gave them that. Next year, 2011, people started to download it. Who is now my boss, Richard Baitlick. He started tweeting about Security Onion in 2011, and so when Richard Baitlick, who has 20,000 Twitter followers, starts talking about something, people listen. And so folks started downloading it, and to my surprise, they started deploying it, right? So I had really designed Security Onion primarily to be like a training tool, like for a classroom or a lab environment. There's a big difference between, having an ISO image that you can just fire up and play with and having an actual distro that you can run and keep updated and maintain. Because all along I had just been releasing new ISO images every couple of months. So if you're running a production sensor and I release a new ISO image and you want to update, you've got to wipe your sensor and install the new ISO image. It doesn't really work for production environments, right? So I had to come up with an in-place update method. So I wrote a little shell script so I could deploy some packages. And via that shell script, we deployed Bro. Bro is an amazing, amazing network sniffer that provides you all this amazing intelligence about your network. Also included Network Miner, which is a great graphical tool for doing PCAP analysis. And Snorby. Snorby is this Web 2.0 Ajax Ruby on Rails interface for IDS alerts. It's awesome. So made a lot of big changes in 2011. Then 2012 rolled around, Ubuntu released 12.04, so it was time to rebuild the distro again. So I said, okay, now it's time to put on the big boy pants and really do it right. Okay, so what we did is we took every single piece of software and built true Ubuntu packages hosted by Ubuntu's Launchpad PPA service. So basically we create a source package, submit it to Ubuntu, they compile it for 32-bit and 64-bit, and they host it for us for free. That's awesome. So now that means that we've got a standard PPA, just like the standard Ubuntu repo, so you can use the standard Ubuntu tools to update your distro. Previously we were using Snort and then Daemon Logger for doing our full packet capture. We replaced that with NetSniffNG because it uses zero copy and it can get to much higher levels of traffic before it falls over like Snort and Daemon Logger did. The other thing that we did for high performance is PF-ring. Who's got familiarity with PF-ring? A couple of people? So PF-ring is a kernel module and a user space library that acts as a flow-based load balancer. So let's say I've got a gigabit of traffic that I want to monitor, right? If I try to take one instance of Snort and monitor 1 gigabit of traffic, what's going to happen?
Probably crash.
What's that?
It'll probably crash, run out of memory.
Probably crash or run out of memory.
Drop packets.
Drop packets, right? So Snort is single-threaded. So what's going to happen is once you get up to about 200, maybe 300 megabits a second, Snort's going to hit 100% CPU and instantly start dropping packets. That's bad. We're now missing attacks. But if we can take that gigabit of traffic and we can partition it into, say, 4 chunks and spin up one stored instance for each of those chunks, we can handle that, right? We can have one stored instance handling 250 megabits, that's fine. So we compile snort and suricata and bro against PF rings so we can spin up multiple instances, handle lots of traffic. We also added ELSA. ELSA is this great web-based interface for hunting through logs. It's kind of like Splunk, except it's not going to cost you $1 million, right? Splunk is great if you have 500 megabytes a day or less of logs. That's the free license. But as soon as you cross that 500 megabyte threshold, it costs, and it costs a lot. ELSA is totally free, totally open source. It allows you to manage billions of logs and slice and dice those logs with ease. I like big onions and I cannot lie. So I mentioned the fact that we have 64-bit capabilities now. If you download our ISO image, it is 64-bit by default because we want folks to handle big networks with big traffic. We want to be able to build big onions to handle that. So we do 64-bit by default. If you really want to strip it down, instead of using our ISO image, you can start with Ubuntu server, so no GUI whatsoever. You can grab Ubuntu server 64-bit, add our PPA, add our packages, and be up and running in just a few minutes. I mentioned before that we're compiling snort, suricata, and bro against PF ring. We're using NetSniff and G for high-speed full packet capture. And then ELSA is really this amazing distributed database because by default, when you start spinning up your security onion sensors, each sensor is spitting out all these bro logs. And you may also have OSEC logs. You may also have standard syslog as well. Well, each sensor has its own MySQL and Sphinx databases. MySQL is a database, Sphinx is an indexing overlay. The ELSA web interface is going to query all of those in parallel. It looks like this. So you log into the ELSA web interface, you issue a query and say, hey ELSA, what do you know about this IP address or this domain name? And it's going and querying all of your sensors, all of those MySQL and Sphinx instances in parallel and returning you an answer in milliseconds. Right? So you don't have to worry about one central database getting big and bloated and slow. As your sensor deployment grows, your database automatically distributes itself. Here's a picture of what ELSA looks like from an input standpoint. So it's based on syslog-ng. So we can use syslog-ng to ingest standard syslogs. If you've got standard infrastructure devices on your network and you can point them at a syslog collector, we can ingest that. Anything that comes in via syslog-ng, it's piped into elsa.perl. ELSA is written in Perl for you Perl mongers out there. And then the data gets loaded into MySQL, and then Sphinx comes along and indexes all of those MySQL tables, and then it consolidates those indexes. And then finally, you as the analyst, you're here, you issue a query for the web API, and it goes and searches Sphinx. Sphinx says, oh, I know where that is because I've indexed those databases, and it gives you a list of document IDs. The web interface goes and retrieves the raw logs from MySQL and hands it back to you. And again, this all happens in milliseconds. All right, so that was 2012. So this year, 2013, we did release at the very end of 2012 what I call the BDR, the Big Distro Rebuild. And 2013, time has gone on, new versions have been released. So we've updated just about everything from snort to suricata to PF ring to prads, ELSA snorby, that whole list there. The software that we've developed for Security Onion itself, the bash scripts and other things that kind of glue everything together. We had bugs, yes, we're imperfect too. We fixed those bugs. We added more knobs for tuning so folks can have more control over the way their deployment is built. So, some folks may not want to run things like Argus, so we make it very easy to turn Argus off and other sensor processes. You can totally customize what things are running. And then another thing, which I'll show in the demo later, is when you're looking at HTTP traffic, the vast majority of HTTP traffic these days is gzip encoded because Google and other big web server farms, they want to save bandwidth as much as possible. So they gzip it before they send it. But when you look at that as the analyst, when you're digging into your full packet capture, when you see gzip data, it's just binary garbage. You can't read it. So my good friend Scott Runnels, who's kind of my right-hand man on the secure gaming project, he came up with this bro script, which will take your transcript and automatically unzip that gzip encoded response. And that's pretty awesome. Some metrics, folks always ask, well, how many folks use it? The old version based on Ubuntu 10.04, we had 37,000 downloads from SourceForge. At the end of 2012, we released the 12.04 version. We've had 34,000 downloads of it. In June, we released 12.04.1. We've had 7,000 downloads of it so far. In July, we released 12.04.2. We've had 5,000 downloads of it. This past weekend at B-Sides Augusta, we just released 12.04.3. So we probably have a few hundred downloads of it. And then finally, we also have BitTorrent available. Of course, we have no idea how many folks use BitTorrent, so that's a big question mark. And then, as I mentioned before, you can install your preferred flavor of Ubuntu, add our PPA and packages, and we have no download counters for that. So the gist of it is, we got lots of users, right? We have this big community built up that's worldwide, lots of folks using it in production and finding evil every single day. So this slide was from Saturday. Yes, we released the 12.04.3 ISO image. We've made some changes since 12.04.2. We added a new script called Soup, which makes it a little easier to handle some of our problematic updates. We put out new versions of PF Ring, Snort, Suricata, Squirt, CatB, Network Miner, and our Bro scripts. So we're not standing still, we're moving forward. One of the new features that we added is called Salt. Anybody familiar with Salt at all? One person. Anybody familiar with Puppet? A couple more people. Okay, so Salt is kind of like Puppet. It's a system for configuration management and remote execution. And so we've integrated Salt directly into Security Onion. So if you enable Salt, right, your master server, the first one that you build, becomes your Salt master. Your sensors become Salt minions. These minions communicate with the master, and it's an authenticated, encrypted tunnel. And so what happens is this master can tell the sensors to do whatever, right? And I'll show this in the demo, but you can do anything from out of the box. So you can go to your master and you can add your users. So I'll add a Lawrence user to my master. I'll add myself as a user. I'll add SSH public keys for both of us. And then those will get distributed automatically to all my sensors, right? So you no longer have to manage. If you've got 100 sensors, you don't want to manage them one by one. Right? You want to manage them as a cohesive whole, as one deployment. So we can do that now.
Does that, can you use that to actually harden the application itself, like a SQL database or the OS? It'll reach down that far into it?
Sure. You can do anything you can do from the command line, you can do via Salt. So I'll show this in the demo, but you can do basically sudo salt star, meaning all boxes, command.run, whatever command you want to run. It sends that out to all the Salt minions, they execute it, their standard out goes back to the server. And then it shows you that whole list from all the sensors in your deployment. And then you can do things like, configuration management. I want Salt to automatically, make sure that my snort.conf always has this home net, right? So whenever we push out a new snort package, it reverts your home net to the default RFC 1918. But if you have something different, you can have Salt change that whenever it reverts.
Can you script rights and privileges and all that kind of stuff in there?
Anything you want to do. Yeah. The sky's the limit. All right, so just a quick review of data types. I said before that the whole world is stuck on this idea of network-based IDS alerts, but network security monitoring says network-based IDS alerts alone are not enough. We need to surround that with contextual data. So we add host-based IDS alerts coming from OSEC, syslog data coming from your standard syslog devices being received by syslog ng, asset data coming from Bro and Prads, session data coming from Argus, Bro, and Prads, transaction data. So this is when I said before that Bro gives you all this amazing intelligence about your network. Every single HTTP transaction it sees on your network, it's in HTTP.log. Every single FTP transaction it sees is in FTP.log. What would you give to have a copy of every single DNS request and response in your network? Do you have that today? Does anybody have that today? One guy does. Two guys do.
I have a question about
No, just one guy does.
Does Bro just log it, or can you view all of this data within Bro as well?
So Bro is creating these standard ASCII log files. we have syslogin G configured to monitor those log files and import that data into ELSA. Right? So you can go into ELSA and you can say, hey ELSA, show me every single DNS request on my network grouped by host name. So you can see all the unique host name requests on your network for the last 24 hours, 48 hours, what have you. You can look at all the HTTP requests on your network grouped by site.
By requests, do you mean simply like a GET request, or do you mean the full headers of that? Like what is it? What is it capturing?
It depends on the log type. So like for a DNS log, you're going to see this workstation requested this DNS name for this DNS server, and the DNS server responded with this response. For an HTTP log, you're going to see a lot more data. You'll see things like this workstation sent an HTTP GET request to this server for this URI. Here was the response code that came back from the server. Here's the user agent string, and so on and so forth.
One more thing. Is this referencing the PCAP you're already capturing, or is this redundant to some of that?
So Bro is doing its own logging that's totally separate from the PCAP store. So there's a little bit of overlap there. I mean, you could go into your PCAP store and you could extract this information manually. But Bro is logging it so that we have it in ELSA automatically, so that we're not having to do like an ad hoc query of our PCAP store and wait for that session to be pulled out of this ginormous PCAP store. So we have this information at our fingertips instantly. Did that answer your question?
Thank you.
So we've got Bro logs and we've got full content data coming from NetSniff and G. All right, so would you guys like to see a live demo?
Yes.
Are you sure? Okay, I just have to ask. All right, so this is Security Onion 1204.3. It's based on Ubuntu, so I've booted the ISO image. I've run through the standard Ubuntu installer. Has everybody here installed Ubuntu before? Most people. It's easier to install than Windows, right? Much easier, much faster. So that generally takes 5 minutes, right? So you're done with the Ubuntu installer in 5 minutes. You reboot into your new Security Onion installation. Then we have this setup wizard on the desktop. There's 2 phases to setup. The first phase is identifying your network interfaces, right? So for your typical sensor, you're going to have one interface that's dedicated for management. That interface is going to have an IP address. That's what you're going to use to SSH into it. Or if it's the master server, that's where you go to visit the web pages for Squirt and Snorby, so on and so forth. If it's a sensor, you're going to have additional interfaces that are dedicated for sniffing, right? So you may have one or more of those. So the first phase of setup identifies what network interfaces are doing what, and then we reboot, and that's where we are right now. So we're ready to do phase 2 of setup. So welcome to Security Onion Setup. Would you like to continue? Yes, I would. Setup determines that we've already configured our network interfaces. We don't need to do it again, so we can skip that part. First question is, would you like to use quick setup or advanced setup? So for those of you who are going to go home tonight, you're so excited about Security Onion, you download it and you fire it up. We recommend that you run quick setup. If it's your first time, it's going to ask you the minimum number of questions to get you up and running as quickly as possible. Once you've installed it that first time, played with it, kind of understand the lay of the land, then you can go back and run advanced setup. It gives you more control, but it asks you more questions and requires more information. So quick setup is very simple. I do want to show you some of the advanced stuff, so we'll do advanced setup. All right, so if you're doing a production enterprise deployment, you're going to start off by building your master server first. So we would choose server. It's just a server, it's not a sensor. After that, we start deploying our sensors, right? So for those, we choose sensor, and those sensors are going to communicate back to the server. In this case, we want everything on one box, so we're going to do standalone. All right, so here we're going to create a username and password for Squeal. Put your email address, doug@burks.com. We're going to set a password. Which IDS engine would you like to use? So Snort and Suricata are totally interchangeable. You can choose whichever one you want, and they both work well. We'll just choose Snort. Which rule set would you like to use? Security Onion comes with a full copy of the emerging threats GPL rule set built right in. So even if you don't have internet access, it's built right in, so you can use that. If you do have a paid subscription for some of these other services, you can use those as well. Which network interfaces should be monitored? So for this VM, I have 2 interfaces. E0 is my management interface. It has an IP address. It's what's used for accessing the web pages and SSH. Ethernet 1 is my sniffing interface. It has no IP address. The offloading functions are turned off. That interface is optimized for sniffing automatically by our setup wizard. So we'll do Ethernet 1 for sniffing. All right, so here's where we get into selectively enabling and disabling sensor processing. So the first question is, would you like to enable the IDS engine? So this would be either Snort or Suricata. Yes, we do want to enable that. Here's where we get into the PF ring configuration. So remember I said that PF ring acts as a flow-based load balancer, allowing us to spin up multiple Snort instances to handle high amounts of traffic. I've got 2 CPU cores in this VM, so I can spin up to 2 Snort instances. I'm only going to do 1 just because it's just a demo. We don't need lots of traffic. But you do have that option. Would you like to enable Bro? Yes, you do want to enable Bro. It gives you amazing intelligence. And then the PF ring configuration for Bro, we'll just do 1 CPU core dedicated for it. Then we have this thing called HTTP agent. So Bro is watching traffic, it's creating this HTTP log. We have this other process that comes along, the HTTP agent takes those logs and sends them into our Squeal database. So that from the Squeal client, you can actually pivot, you can see all the HTTP transactions. So yeah, we'll enable that, that's kind of cool. Would you like to enable Argus? We don't really need it for this demo, so we'll disable it. Would you like to enable PRADS? Yeah, for this demo, it'll give us some cool functionality, which we'll see in a minute, so we'll enable that. And yes, we do want full packet capture. Full packet capture is huge. It's the videotape that we're going to go to. So you can specify how big you want your PCAP files to be before they rotate to a new file. Default to 150 megabytes. And then we have this hourly cron job that monitors your disk usage. And as soon as you hit 90% by default, it's going to start purging your old PCAPs and old log files. That's totally configurable here, but we recommend that you keep the default. And finally, we do have Salt, which I mentioned is a new feature. So we do have it tagged as experimental, but I do want you guys to see what it can do, so we'll enable that. And we do want to enable ELSA. So finally, we come to the confirmation screen. So setup says, okay, I've collected all the information, make sure this is what you want to do, proceed with the changes. So right now what's happening in about 3 minutes, the setup wizard is going to do all of those things which used to take days and weeks and months of compiling software and editing configuration files and testing things and making sure they work properly. All this stuff is just happening for you. So it's initializing the Snorby database. I'm going to show you 4 interfaces tonight. Snorby is the first one I'm going to show you. It's Web 2.0, it's Ajax, it's Ruby on Rails. It's a beautiful web interface. The downside to Snorby is that it's limited to just IDS alerts. And so as we go through this demo, you'll see that because it's just IDS alerts, it limits the amount of investigative capability that we have. Right? So that's when we start moving on to some of our other interfaces. Now, as I go through these interfaces, keep in mind the order in which I show you these things. This isn't like a recommended workflow. This isn't what I'm telling you to go and do every single day. What we recommend is that folks play with each of these tools and figure out which tool best suits your organization's workflow, right? Because different organizations have different needs, and so we don't dictate one interface or one tool. You pick what's best for you. All right, setup is now complete. We're done, right? So we did 5 minutes for the Ubuntu installer. We did a few minutes to run through the setup wizard, and we're up and running, okay? We click OK a couple of times. Now we can go to our terminal window. So the first thing I'll show you here is Salt, right? So imagine that this is a full enterprise deployment. This is our master server, and imagine we had 100 sensors all connected to this guy. So you can do things like sudo salt star test.ping, And that's just a simple test just to make sure that the minions can talk to the master and vice versa. So the next thing we can do is we can do command.run service NSM status. So again, it's going to take that command, it's going to send it to all the salt minions. They're going to execute the command locally on their own instance, take standard output, send it back to the master server. Right? So we just see one output here, but if we had 100 sensors, you'd see it from every single one of your sensors. So as you can see here, we've got our entire stack up and running. We've got the Squeal server, which is kind of the heart of everything. We've got the OSEC agent, which takes all the OSEC logs, sends them into Squeal. We've got Bro up and running. We've got NetsniffNG doing full packet capture. We've got Snort doing network-based IDS. We've got Prads doing session data and asset data. And we've got some agents here which take that data and put it in the right places. All right, so everything's up and running. That's pretty awesome. So the first thing I'll do is, since I'm not connected to any networks here, I don't have any traffic. But lucky for you guys, I happen to bring some traffic with me. So in cybersecurity, I mean, we do have some PCAP samples built right in. So we can use our old friend TCP replay. And I'm just going to do one sample to start with, so I can check a log file and make sure things look good. So our bro logs are at NSM bro logs current. And we have this thing called the con log, which is a connection log. And there we can see IP addresses, and everything looks good there. So now that the test is working, I want this PCAP. And I want this PCAP, and I want this set of PCAPs. All right, so we're monitoring traffic. Woo! So now what we can do is start looking at our interfaces. So the first thing we're going to look at is Snort. Just ignore that nasty red warning. Trust Doug Burks. He's cool, I know. So again, Snorby is Web 2.0 Ajax Ruby on Rails, written by a guy named Dustin Weber and his team at ThreatStack. We're going to log in here using the email address and password that we specified in setup. And we're going to go force a cache update. All right, so we've got our lovely Snorby dashboard. We've got some high severity stuff, some medium severity stuff, and some low severity stuff. You can click into this, so if you just want to see the high severity alerts, you can click right into that. You can scroll down here and you can look at your sensors, your severities, your protocols, your signatures. You can hover over these things and get nice pretty pop-ups. You get nice pretty colors for the management types. You're going to go nuts over this stuff, right? Sources, so you can see your top talkers on your network. All kinds of cool stuff. But now me as an analyst, you know, I don't care that much about dashboards. I want to see some real data, right? I want to go over to events. This is going to be where all my IDS alerts are, right? So you see your standard IDS alerts here. We have emerging threats, IDS alerts, and some GPL alerts. So let's go down and let's find an interesting alert. So let's look at this one right here. This is an emerging threats policy alert for a suspicious .doc.exe in an HTTP URL. All right, so this is going to be our case study for tonight. Okay, so let's first start off by looking at the rule itself. So this is the snort rule that generated the alert, and it's just looking for content.doc.exe. So somebody tell me, why would I care that I see .doc.exe in my HTTP traffic?
It's an executable masquerading as a document, a Word doc.
It's an executable masquerading as a Word document. Very good. So let's come up with a possible scenario here. And this isn't just hypothetical. This is real world, right? So spear phishing, right? Your users receive spear phishing emails every single day. right? So let's talk about a spear phishing email. So attacker crafts this email that says, hey, Joe Blow, I found this Word document and it appears that you're going to be laid off next quarter. So you might want to click this link, right? So they look at the link and it looks like a Word document, right? So they click it and guess what? It's actually an executable, right? So it's bad, right? So we need to investigate that. So we can look here and looking at the detail of the IDS alert, we have the source IP, so here's our workstation IP address. Here's the destination that the HTTP GET request was sent to, source port, destination port, all the standard stuff. We can look down to payload, we can switch to ASCII, clean that up a little bit. So, first question. You see the HTTP GET request here. Is this IDS alert a true positive or a false positive? It's a true positive. Very good, because we looked at the rule and we saw that the rule was looking for a content of .exe, which we see right here. This is a true positive. Okay, follow-on question. Do we care about this?
Very much so.
Very much so, okay. So, next question. The user requested the .doc.exe. Did they actually get it? Do we know? Based on the IDS alert alone, we cannot answer that question. The IDS alert just gives us the GET request and the headers coming from the client. We don't see the server response. This is just a snapshot in time. What we need is videotape, right? Well, guess what? I got your videotape right here. Packet capture options, custom, fetch packet. Put in our username and password. All right. So let me, no, that's fine. So here you see the GET request. This is just what we saw before. But what do we see beneath that? We see the response from the server. All right, so let's ask the question again. The user requested the EXE. Did they get it?
Looks like it.
It appears they got it. Why do you say that?
They got a 200 OK with some payload.
They got a 200 OK, HTTP 200 OK, and they got some payload. What's this right here? Yeah, so you see MZ at the beginning of a file. Chances are that's a Windows executable. Bonus trivia question. Does anybody know what MZ is? What does it stand for? Ooh, I got you guys plotting and scheming now. Anybody know? MZ are the initials of the gentleman who worked for Microsoft who actually invented the DOS executable file format. So he put his name on every single executable in the world. Then you see this program cannot be run in DOS mode. Yep, good chance this is an actual executable. What do we see down here? Anybody see that? What is that?
Back home to the mothership.
Oh, phoning home to the mothership. Yes, we have a connect string. So this is a piece of proxy-aware malware that's able to issue a connect string to a proxy and actually get out to the mothership. Okay, that's pretty cool, or pretty scary depending on how you look at it. Let's see what else we can see in our full packet capture. So we scroll down. Hey, what is this right here?
IP address.
Oh, an IP address. The plot thickens. That's kind of cool. So, we have an EXE that got downloaded, and it had a connect string in it, and it's got an IP address. So maybe if the user executed that and it phoned home to this IP address, maybe we should search for that IP address and see if we see any traffic for it. Sound like a plan? All right, so let's copy this, and let's go back. So now in Snorby, it has this nice little search facility. So we can say, hey, show me anything where the source address is this 221.
Source or destination?
I'm going to do an OR.
Okay.
Because I could have traffic in either direction. I could have, depending on what things look like. So I'm going to do source or destination is that. So basically, any IP address anywhere is this thing. Submit search. Oh, bummer. Okay, so, yes, sir.
Can you rebuild the file for your PCAP?
Sure. I'm going to show you that very soon. Don't rush me. Good things come to those who wait. Okay, so we did a search inside of Snorby for that IP address. So, did the user execute the exe? I'm hearing some yeses, I'm hearing some no's.
Maybe
So you don't know is the
I
answer.
hear a maybe?
You don't know yet.
It's inconclusive.
Yeah,
Why is it inconclusive?
because you haven't looked at your HIDS log yet.
What's that?
You haven't looked at your hostbase IDS log yet. Find out.
Yes, we haven't referenced our other data types yet. Remember, Snorby is just network-based IDS alerts. That's it. Okay, so Snorby's very cool. It's beautiful. I see you guys drooling out there over how pretty the web interface is. But we're going to move on to Squirt. Okay, it's going to give us a little bit more data. And again, this is not necessarily a recommended workflow. I'm just showing you the different tools and the different data types that they present to you. All right, so in Squirt, I can go up here and I can say IP space and this IP address. Hey, look at that. We found something. Boy, that's interesting. So we found a PADS new asset event for an HTTPS site. So we passively determined that there's an HTTPS client connecting to an HTTPS server. That's pretty interesting, right? So here's our workstation IP address again, connecting outbound to the suspicious IP address. Okay, so let's ask the question again. Did the user execute the malware?
Yes.
We're pretty confident that's a yes. Okay? Very good. So now, let's take the user's IP address.
So the log you're looking at there, though, that came off the HIDS, not Snort. That came out of OSSSec or whatever the.
It actually didn't come from OSEC.
Okay, so
what
how
this
come we
came
saw it
from
here, not the other
was
place?
passive network sniffing. We have a tool called PRADS, which does passive asset detection. And so it's monitoring network traffic, and it doesn't operate on snort rules or anything like that. All it does is say, hey, I saw this workstation right here connect outbound to this IP address, and I've never seen it connect to that IP address before.
Gotcha.
Right? It's a new event, something interesting.
Is it using the session data, like your NetFlow, or?
It's creating session data, but the PADS new asset event itself is not necessarily based on the log session data. It's just something that it's keeping in memory. Hey, I remember seeing that IP address before, or no, I don't remember seeing that IP address before. Communicate on those ports.
So the Snorby search only looks for IDS alerts that match that contain that IP, whereas here you're doing packet capture that matches it. Or
Snorby
flow that
only
matches
has
it.
access to network-based IDS alerts from Snort or Suricata.
Okay.
What you're seeing here is another data type created by another tool. So you have, if you remember that big squeal diagram that we had, down here near the bottom was a tool called PADS. It's now called PRADS. That's a network sniffer, and it's creating two types of data, session data and asset data.
Okay.
Both those types of data go into the Squeal database, and Squirt is a web interface to the Squeal database. Got it?
Yep.
Excellent. All right, so we're going to take our workstation IP address, copy it, paste it up here. So now we're saying, hey Squirt, show me everything you know about this workstation IP. We have a pretty good feeling is compromised. Okay, so we see, oh, ghost rat. Yeah, things just keep getting worse all the time. Okay, so is our confidence level getting higher that this box is really and truly popped?
Yes.
Yeah. Okay, so let's see. Let's look at our PADS new assets, and let's see what all we have. So we had the one that we looked at before that was the HTTPS outbound to the suspicious IP address. But then we have this one here. So our workstation IP address, we saw a connection to an FTP server hosted outside of our network. Should we take a look at that? Yeah? Okay. So I want to access full packet capture, and to do that, I need to do a little bit of work in Squirt. So let me just do this. And you can just pretend like you don't see my clear text username and password. It's top secret. Don't tell anybody. Okay, so I say, you know what, this FTP session is interesting. I need full packet capture, so I click on TX, generate transcript. So this is going to generate an ASCII transcript, just like we saw before in Snorby when we pivoted to full packet capture and it gave us this nice red and blue transcript. Same thing here. But check this out. This is an FTP transaction. So we see the workstation logging into the FTP server as user Jack, and the password is 2. Awesome. All right, so then what do we see? Once it's authenticated, what does it do? What does the FTP store command do? Uploads a file. So we uploaded a file called one.txt. What else happens?
Put in another one called 2.txt.
Very good. We uploaded a second file, 2.txt. Well, those are some creative file names. Obviously dealing with a very sophisticated attacker here. So maybe, you know, the hairs on the back of my neck are really standing up. I've got all these alerts. I've got this high confidence level, this workstation is compromised. I've got an FTP connection, and 2 files are being uploaded. This kind of feels like exfiltration, doesn't it? Maybe. So maybe we need to look at those files. Maybe we need to look and see, maybe this is like our intellectual property that just went out the door. Maybe this is social security numbers. Maybe this is credit cards. Maybe we need to look at that. So how might we go about looking at those files? Can we?
Well, it should be in your full packet capture.
Should be in our full packet capture. Okay.
Thanks to clear text FTP.
Nice clear text FTP. Gotta love it. I hate encryption, but I love clear text FTP. So how might I go about actually finding those files in my big, humongous PCAP store? Grep. Okay, maybe that's one option.
You got the source, destination, and time.
Source, destination, and time. So maybe we could do some kind of an intelligent query.
Bro?
Bro, okay. That's actually a very good thought. So I don't normally do this in my demo, but somebody brought that up. So let's just look at that. Bro's got this FTP log. So we actually do see in the Bro FTP log, you see our workstation IP going out to the outbound IP address on port 21, logging in with the user Jack. Bro actually obfuscates the password there and shows you that it's stored 1.txt and 2.txt. It does show us that 1.txt was raw archived data. That's interesting. So Bro kind of gives us like metadata about the FTP transaction. By default, it doesn't actually extract those files. You can configure Bro to do so, but it doesn't by default. So if we actually want to pull those files from our PCAP store, so here's one option. So let me ask a question. This is, or is this, the FTP data connection or the FTP control channel connection?
Control channel.
Control channel, very good. Okay, so, what could I do?
Look at port
See
20.
like a port 20 traffic.
Oh, what is port 20? I'm not familiar with this port. Oh, data, the data channel. Excellent. Okay, so, all right. Let's do this. Let's go to Squeal. Remember, Squeal is this old Tickle TK interface. It's not the prettiest thing in the world, but man, it's highly functional. All right, so if I look through here and I sort by destination port, and I look at port 21, this is what we were just looking at, right? This is the FTP control channel connection. I can pivot on this and I can see the exact same ASCII transcript we were just looking at. Now I want to actually find the data channel, right? So what can I do? In Squeal, just about every single field you can pivot on. So I'm going to pivot on this external IP. And and I'm going to say, hey Squeal, search your SANCP table. SANCP table stores session data. So search your SANCP table for this destination IP. And down here at the bottom, the destination port is 21, so that's our which?
Control.
Control channel. Okay, very good. What do we see above that? Data. Excellent. Okay, so now the plot thickens. From here, we can pivot on the connection ID. Let me do the other one first. Pivot on the connection ID for this port 1370 connection. What do we see here?
User ID and passwords.
So we see gsec dump, which is used for what?
Taking your SAN file.
So dumping your password hashes off a Windows box. Okay. What do we see down here? What is this?
Yeah, it's the help.
Help.
Context
Help
help.
options. Okay, so why would an attacker upload the help options from a workstation to his FTP server?
I'm sure he's got it.
Checking to see if the tool's there.
What's that?
Checking to see if the gsec dump tool is present.
Oh, checking to see if it's present. That's a good idea. I actually hadn't thought of that. I like that. So how about another option? Maybe we're dealing with a sloppy attacker. Maybe he was trying to run gsec dump and he kind of mistyped his options, right? So gsec dump spits out, you're an idiot, here's the options you should be using, right? I love finding sloppy attackers. It's so much fun. They're idiots too, you know? They win, they get stuff, but they're in the end, they're idiots. It's fine. All right, so I get this feeling we're dealing with a sloppy attacker. So now I want to go look, because I'm not really concerned about this, right? This isn't intellectual property. This isn't credit card numbers. I don't care about this. This is not reportable. But let's look at this, right? And when we looked at the Bro FTP log, Bro had identified that one of those uploads was a RAR archive, right? So what do you see here?
RAR.
Yeah, RAR, right there. It's a RAR file. So how do we make sense of that data? How do we tell if that right there is our credit card numbers, or our social security numbers, or our top secret classified data?
Turn it into a file and hope it's not password protected.
Turn it into a file and hope it's not password protected. Very well said, okay? So here's what we can do. We're going to right click on the connection ID, we're going to pivot into Wireshark. So we go out to our PCAP store, we retrieve the entire TCP stream, put that into a PCAP, send the PCAP back to the client, open that PCAP up in Wireshark, and there you go. All right, so we right click, follow TCP stream. Now we save as, and we save it out to our temp folder, out.rar, save that, close that, close that, close that. Now, we've got a file. We have extracted the file from the PCAPs. So, what was the second part of what you said?
Hope it's not password. Well, unrar it if you can. Hope it's not password protected.
Hope it's not password protected. Okay. Yeah. Here we go. Temp, out.rar, double click. Ah, password protected.
And fcrack zip.
What's that?
Fcrack zip.
Fcrack zip. Okay. So, if we didn't have access, if you've got access to a brute forcer, that's great. If you don't, maybe we could say, well, you know, we've seen evidence that maybe this is a sloppy attacker. Maybe he chose a very simple password. Anybody want to guess a password? Password. Let's try it. Oh, no, that's not it.
1, 2, 3, 4, 5.
1, 2, 3, 4, 5. No.
Tried nothing.
Awesome. Try blank.
Too awesome. See, that's what I thought the very first time. That's a good guess. No?
What about the following?
Oh, you're cheating. So Lawrence has seen this demo before, so QWERTY. Bam! We just opened up our encrypted RAR file. Alright, so we open up this folder. There is your exfiltrated data. Right? So depending on what organization you work for, maybe Maybe this is your credit card numbers, maybe this is your social security numbers, maybe this is your top secret classified data. But we have now just answered all the questions, right? Was the IDS alert a true positive? Yes, it was. Did the EXE actually download? Yes, it did. Did the EXE execute? Yes, it did. Was the workstation compromised? Yes, it was. Did the attacker have full control of the machine? Yes, he did. Did the attacker exfiltrate data? Yes, he did. There you go. All right, so that's that use case. I'm going to show you a couple of other things inside of Squeal. So if I scroll down and look for another EXE. So let's say, you know, we find some random EXE floating across our boundaries, and we want to extract that. You know, it makes it very easy inside of Squeal. We can just pivot into Wireshark and go File, Export Objects, HTTP. And we can just save that right out to our file system, start doing reverse engineering on that. The other option that we have is that we've also integrated Network Miner into Squeal. So instead of pivoting to Wireshark, we can pivot right into Network Miner. Network Miner is this great PCAP analysis tool, and the cool thing about it is that it automatically extracts any files out. All you have to do is go to the Files tab, right-click, and open folder, and there's your EXE. Okay, so just a couple of clicks, and you're now carving executables out of PCAPs. All right, so that's Squeal. Squeal's very powerful. I spend all my day bouncing between Squeal and ELSA. That's my workflow. So I use Squeal primarily for alerts that come into the real-time console. I deal with those. If I need to research, I go into ELSA. So again, ELSA is this web-based interface for hunting through your logs. It's based on syslog-ng, MySQL, and Sphinx. And it allows you to take billions of logs and slice and dice them any way you want to, very, very quickly. All right, so you can see in the upper right-hand corner, we have over 18,000 logs already, just based on the little bit of sample traffic that I replayed. So what ELSA is really good at is, you know, when I look at kind of the NSM industry as a whole, you know, we're really moving from this old antiquated idea of alert-driven incident response to more of a hunting. You know, you as an incident responder, you're now proactively hunting through your big data, looking for things, because attackers are, you know, very easily able to evade our network-based IDS, and they can encrypt traffic, and they can do all sorts of things to fool our standard alerts. But we can do things using our intelligent and creative brains to hunt through this data and find new and interesting anomalies that we need to take a look at. So let's just take a look at some logs. And the other thing that I'll mention here is, for the past few days I've been in Arkansas at the National Guard cyber exercise. And so one of the things that they're training for is, as the National Guard, being cyber folks, they are now kind of tasked with the responsibility of, you know, if a wastewater treatment plant facility in your state, if their SCADA system gets compromised, you know, they're going to call out the state National Guard to come and help with that. So now the National Guard has to be able to parachute in and instantly get situational awareness of what's happening on the network. And I really see Bro and ELSA as a really great way of doing that. So I was kind of teaching this hunting technique of getting situational awareness just by doing this. Okay, so we're going to take a look at our Bro con log. This is a connection log, so this is session data. So we're just going to say, show me all the connections you've seen on my network. ELSA comes back in just 200 milliseconds, and we found 7,000 connection records on our network. Okay? Well, that's cool. I don't necessarily want to like page through every single one of these. I don't want to look at them one by one. What I really want to do is take all this mountain of data and collapse it down, do some data reduction so I can manage it, right? So ELSA has this great group by capability, so I can group by source IP. So these are the top talkers on my network, right? I can go back here and I can group by destination IP. These are the top destinations on my network. I can go back here and I can group by destination port. I can start looking for anomalous ports, like what is this 4445, right? So you do this every day. You establish this hunting routine and you start to establish a baseline for your network so that you understand what's normal for your network so that when something that's abnormal happens, you can identify it. So those are connection layers. Let's move on to our next road data type, which is DNS. Okay, so we're recording every single DNS request and response on our network. So we've got 67 DNS requests. We can take and group that by host name. Now one thing interesting that you'll see here, if you notice at the top you see workgroup and then you see like MS browse. So Bro actually logs Windows NetBIOS name service requests to the DNS log. Now that's very good intelligence, but if we just want really true DNS logs, we can just filter on port 53. So here's our actual true DNS request, right? So we can start looking through this list and, well, yeah, apple.com, we have some iTunes users, that's normal. Apple.com, Apple.com, what is that? Show. You know, so you look through here, and what is this site in India? You know, and this site in France, well, that's Google, maybe, supposedly, right? So you start looking for anomalies in your DNS data. So then we can move on to our next log type, which is HTTP. HTTP is so powerful to be able to see every single HTTP GET request on your network. So again, we've got 187. I don't want to go one by one, but I can group by site. And this is very powerful. Again, so we see apple.com bubble up to the top. So think about on your network, right? You're going to do this, and you're going to see google.com bubble up to the top. You're going to see MSNBC bubble up to the top. Bubble up to the top. But then you see things like rapidshare.ru. Right? Why is my user going out to Russia? What is this? Exploitme.com.cn. I don't have a good feeling about that one. Let's investigate. So we drill into that, and we see, okay, this is an HTTP GET request for exploitme.com.cn. This random string of text. The referrer was this Russian site that we were questioning before. So this user went to this Russian site, which led to this Chinese site. That's really bad. So again, we want to investigate this. The Bro HTTP log gives us kind of some metadata, but it doesn't give us the full transcript. That's okay. We can pivot. So we click on Info, plug in get PCAP, pivot over to our CapMe web interface. All right, so here you go. This is the entire TCP transcript for that conversation. We see the GET request from the workstation, going to exploitme.com.cn. We see the referrer field, that Russian site. Then we see the response coming back from the server. Scroll down, we see another GET request coming from our workstation. We see the response coming back from the server. So, what is this down here?
gzip.
Oh, it's gzipped. Oh, okay. So I can't read that because the server compressed it before it sent it. But if I go back and I render the transcript with Bro, remember we said we've got this Bro script that will decode that gzip encoding. Now, whereas once I was blind, now I can see, right? This is obfuscated JavaScript. We would have been able to tell that just by looking at that gzip before.
Can Bro deobfuscate that for us too?
I'm sure there is a way to do it.
In the next version.
The next version. It's always in the next version, right? So, the last thing that I want to show you in ELSA is this next log, which is the notice log. So, Bro has this concept of a notice, which is not necessarily bad, not necessarily evil, but not necessarily good. It's just something you want to, well, you know, notice, right? Take a look at this. So I've got 14 notices. I can group that by notice type. And then I can see I've got some invalid server certs. So for every single HTTPS connection, Bro takes a look at that SSL certificate exchange. looks at the cert, walks it all the way up to the root, and if there's anything amiss in any of those fields, then Bro will alert and say invalid server cert. Incorrect file type, so for instance, you do an HTTP GET request for like .php something something, and you get back an executable, right? It didn't match, you didn't request an executable, but you got one, then Bro is going to alert you to that. And then MD5. So this is very, very powerful. Anytime Bro sees a Windows executable crossing HTTP, it's going to take that Windows executable and automatically create an MD5 sum for it. Okay, that in and of itself is cool, but what it does next is going to blow your mind. Okay, so it takes that MD5 sum and it submits it to the Team Cymru malware hash registry. So if the malware hash registry says, yep, I've seen that before, that's malware. It's kind of like an automatic antivirus check on your network for free. Right? You're not paying for any of this, it just happens. So that's very cool. So that's ELSA, that's Bro, that's hunting. Very basic hunting. So, I showed you Snorby, I showed you pivoting from Snorby, I showed you Squirt, I showed you Squeal, I showed you Network Miner, ELSA, pivoting from ELSA. ELSA's got dashboards, so if you like nice pretty colors and graphs, you've got those too. We talked about slicing and dicing and pivoting. Alright, so now that I have preached to you the gospel of Security Onion, you're ready to go download it. You can go to securityonion.blogspot.com. Right to on the right-hand side of the page, you'll see a bunch of links for download, install. We've got a frequently asked question. We've got mailing lists. We've got an IRC channel. We've got a Twitter account, Security Onion. I've got some classes that I'm teaching soon. So I'm teaching a log management class for SAMS in Memphis on October the 16th and 17th. So that's where you can find more information about that. I'm going to be teaching an 8-hour class on Security Onion in Augusta, probably the 3rd or 4th week of October. So stay tuned for details about that if you're interested. Very reasonably priced. And one last thing, in case you don't want to download the ISO image tonight, my good friend Lawrence, he has copies right over there. So go introduce yourself to Lawrence, shake his hand, tell him thank you for the DVDs and thank you for all the B-Sides Augusta support and for riding with me tonight. Thank you, Lawrence. So, any questions? David?
Is there a easy mechanism to reduce a certain false positive that you get on a regular basis?
Is there an easy method to reduce a certain false positive that you get on a frequent basis? A couple of methods. So what I would recommend first is if it's an IDS alert, like a standard snort-based IDS alert, that you just don't care about seeing ever again, you want to turn it off. We use pulled pork for rules management, so you would go into the pulled pork disablesid.conf file, and you're just going to plop the SID right into that file, and the next time pulled pork runs, it's going to turn that rule off altogether. You'll never see it again. Now, if you want to get a little bit more granular, there's other ways of doing it. So with Snort, you can do thresholding. So you can go into the threshold.conf and you can say, well, I don't want to turn the rule off altogether, but I want to ignore it for this particular IP. So you just go in threshold and say, suppress this alert for this IP. And then the other option is, Squeal has a concept of AutoCat, auto-categorization. So you go into Squeal's autocat.conf. And it's got a very customizable kind of regex kind of a way of saying, you know, I can either match on the name of the rule or the IP address or the network or the severity, and I can just automatically categorize these things so they don't fill my Squeal console. Yes, sir?
So what's next for Security Onion, the roadmap?
Oh, what's next? So we actually do have a roadmap page. We generally only project about a month or two in advance. So let's see, we're going to do a new version of Squirt. So Paul Halliday had just released Squirt 1.1. As soon as he released it, we packaged it and we found some bugs. So he's fixed those bugs, so now we have to package it and release it. I have some things I want to do on CAPME, which is the web-based interface we use for pivoting to transcripts. So I really want to get to the point with that where, so right now with CAPME, you really just get a transcript. But I want to make it such that you can actually get the PCAP itself. So pull the PCAP so that you can open it in Wireshark. And then we have coming very soon new versions of our ELSA packages. So ELSA, because Martin Holste, the guy who wrote ELSA, he now works for Mandiant, and for the past 2 weeks, he has coded 10,000 lines in ELSA. So he has added some big new features, fixed a whole bunch of bugs. So we're going to get those packages rolled out. Bro 2.2 should be coming out hopefully in the next month or two. We definitely are itching to get that done as well. So lots of big things coming to the project very, very soon, by the end of the year. Yes, sir.
What's the biggest production environment you know of that has implemented security yet?
That's a good question. So I've asked our community many, many times for metrics, for feedback on number of sensors, amount of bandwidth monitored. For whatever reason, folks aren't willing to share that information. I don't know, it's like they're security folks and they're paranoid or something. But I definitely know of some installs that are 20, 30 sensors. I spoke with a guy the other day who was just about to start a deployment that was 60 sensors. So yeah, there's some good sized deployments out there, and these folks are deploying on big hardware on pretty good sized networks. So if you end up deploying it and you're willing to share information about your deployment, I'd love the feedback. Because next time I do this talk, the same guy or some other guy is going to ask that same question, and I'd like to have some answers.
And is it still 1 gig of RAM per interface that you're monitoring, recommended?
That's our minimum recommendation. So what we tell folks is to buy a whole lot more sensor than you think you need, because number one, hardware is cheap, but incidents are not. So I'd rather spend a little bit more money on hardware up front rather than have the chance of dropping packets, missing attacks, not having the forensic evidence that I need to maybe take it to, make a case on it. So, what I've been buying recently is like a Dell PowerEdge R720 fully loaded. So we're talking like 128 gigs of RAM, 20 terabytes of disk space, 24 CPU cores. But even with all that hardware, you're only talking like, less than 15,000 bucks, which is actually very reasonable when you start comparing that to, if you're going to go buy a commercial IDS appliance from a commercial vendor, you're going to spend a whole lot more than that, and you're just getting IDS alerts. You're not getting row logs. You're not getting full packet capture. You're not getting all the other data types that we discussed that you guys understand now that you really need, right? So we're not charging you for the software. We're not charging you for licensing. Take that money that you save there, spend it on your hardware. Yes, sir.
Do you have IPS plans in the future?
So IPS is a philosophical debate. I am philosophically opposed to IPS. So the problem with IPS is the fact that the second you go in line and you start blocking traffic, you're going to block legitimate traffic. And the second that happens, you're not going to have VIP breathing down your neck saying, rip that thing out of the network because I couldn't get to ESPN.com this morning.
It's happened.
Yes, I know it has. That's exactly why I said that.
Sounds hypothetical, but no.
It happens all the time. So let me quickly answer. So a lot of folks ask that question. I have no interest in pursuing IPS. I know of folks who have taken Security Onion and modified it to work as an IPS. We're not going to do that out of the box. We're not going to support that, but it can be done. Yes, sir.
Let's talk about the ugly elephant in the room, IPv6.
IPv6. Oh,
Some
why'd you have
people
to
are
ask that
full
question?
stacking and not paying attention to that.
Yeah.
Any ideas?
So most of our sniffing processes do have good IPv6 support. Where we are currently lacking is some of the database schemas and the user interfaces don't have full support for IPv6 yet. But as you said, it's the ugly elephant in the room. It's on the roadmap for all of the projects that are involved. So it's going to happen. It's just a matter of time. Yes, sir.
You mentioned about SCADA protocols. I think Bro has support for some of those. Have experience in there. We can follow up offline also.
I don't have any experience with any kind of SCADA environments. I do know that, as you said, Bro does have some support for that, and they recently got a grant to do a whole lot more work on the SCADA side of the house. So that is coming. Chris, are y'all covering that in the book at all? Just a little bit?
Just a hair, yeah.
What other questions do you have? Yes, sir.
I noticed when you were trying to search for the attacker's IP address, what happens if the attacker is using a proxy and rotates their IP every time it makes a new move?
Right, so it's a common tactic, right? An attacker, if they're in any way sophisticated, they're not going to attack you from their own IP address. They're going to use a hot point, probably multiple hot points. Right, so that's when hunting really comes into play. So you may not be able to fill in all the blanks just by doing a simple search just based on this one IDS alert, just based on this one IP address. You may have to start doing some more hunting, doing some more digging in ISSA, and getting a little bit more intelligent about your searches so that you can kind of pull the string and piece all these things together. But yeah, we've got all the data there. It just takes an analyst to be able to piece it